is Daniel Razo. This is my ME210 Video 5 on cylinder testing based on Chapter 16 of the Engineering Mechanics Dynamics textbook. The content I'm going to go over is the real-life example problem, the problem's information, how these concepts relate to Chapter 16, and the key equations used to solve this. So kind of the backstory behind it is that we're trying to test to see how effective cylinders could act as a mean for the device to travel on the ground. Either like cylinders on a board, maybe robots, or like a robot using a cylinder to travel across the ground. So for testing, we're trying to find the angular velocity and acceleration, the velocity at a certain point on the edge of the cylinder, as well as the acceleration. Here's a video of the real test. So in this problem, we have some assumes and givens. We're given the radius of the cylinder, which is 0.0254 meters, as well as we know for sure that point O is the center point of the cylinder, which is right there in the center. The initial velocity is 0.0381 meters per second. Initial acceleration is 0.07 meters per second squared. And then we know that point P is actually 60 degrees from the horizontal line of the floor. And the cylinder is rolling, and we can assume that the cylinder is rolling without slipping. It's a rigid body, it's planar motion, as well as that there are no external factors or forces acting on the cylinder itself. Here are some free body diagrams of the cylinder. The key concepts this problem goes over is relative motion analysis with both velocity and acceleration, rotation about a fixed axis, as well as instantaneous center of gravity velocity. Key equations are like the rolling equation, relative velocity equation, relative acceleration velocity, and the instantaneous center equation.